We've got a lot of really fun stuff to talk about today. A new series of 8mm Rex shaft, the 2106 shafting. I'm sure a lot of you guys have seen already. We've also got some fun stuff to talk about in the line of Strafer chassis. Some small things you can do to maybe improve the overall the kind of general reliability of your chassis over multiple seasons, and some things to keep it in tip-top shape. A lot of you guys, I'm sure, are looking at building strafers for your competition season, so that should be really fun. We've also got some fun giveaways. We've got some Mecanum wheel coasters and some 2106 series Rex shafting. You can enter that in the chat by typing in 2106. No, it looks like it is. There's no more double days. That's awesome. And you can type that into 2106 in the chat, entered to win, is make sure you're following. And if you do end up winning, definitely shoot marketing@gobuilder.com an email and let us know what exactly it is that you won. So the new thing that we have just kind of recently unveiled since our last show is the 2106 series 8mm Rex shaft. So this is an 8 Rex shaft that has a thread on either end. It's a M4 threaded hole. 4 millimeters from one end is also what's called an E-clip. So an E-clip is a kind of shaft retention device that lets you bottom out a bearing or do a lot of generally cool things. The biggest advantage of an E-clip is that over something like a C-clip or a snap ring is that they're pretty easy to remove, which lets you get into some tighter situations if you need to insert a 2106 series Rex shaft, while not necessarily, if you need to insert it in a place where that E-clip wouldn't fit, you can just use like a flathead screwdriver and pop it off. And then once you are in a situation where you want to put it back on, it's pretty easy to reinsert. So that makes it a lot easier. That's why we went with an E-clip. There are two little ears that you can a lot of times get a small flathead screwdriver into and just kind of pry it off. And it's really that easy. Now I've got a really similar to 8 Rex shaft with no E-clip. It's just got a little groove near one end. Those threads on either side are really fun because they let you use it in a bunch of different ways. So one that a lot of teams have been talking about is as a standoff. You can use it as kind of a really heavy-duty steel standoff. So just using those threads on either side, and you can keep that E-clip there, or you can remove it. Either way, if you don't need it. This, of course, lends itself really well to dead axle setups. I've got one actually right here that uses some 14mm ID bearings in the wheel and a hyper hub on one side to clamp onto that shaft. So this 2106 series shaft is stationary, and then the wheel can rotate around that with the bearings in the bore of the wheel. And then you've got a pulley bolted to that wheel that it can rotate around. And that's how you would actually go about driving it and all of that stuff. So they really do add a lot of flexibility to the standard, compared to the standard 2102 series 8 Rex shafting. MC Wolf 04, I haven't had a haircut in a long time. That's actually what I'm doing about as soon as this show is over. I'm just trying to figure out what to do with it because it's so long. But this is, it does add a lot of functionality compared to the standard 2102 series Rex shaft. A lot of the time it can get rid of collars, which is the biggest advantage. You can use that E-clip to just retain a bearing. And that is the primary use case. That's what you're going to do with it most of the time. It'll work in replace, or kind of to replace a collar on both sides. So in this case, I've got a little bit of shaft, 3.5mm of shaft sticking out of the bearing. This would be great if I need to slot it into a piece of channel where I want the flange of the bearing to be on the outside of the channel. You can also have the short end of the shaft stick into the bearing. So now if you want to constrain, this is most commonly used where you want the flanges of your bearing to be on the inside of the channel. So if I were to insert this like this, yeah, and I wanted to have both flanges of these bearings on the inside, you can do that. And that's what this assembly right here uses. where you've got 3 different gears, each with a length of 2106 series shaft. And you can see on this short side, these E-clips are doing all the work of constraining one side of that shaft, and then the set screws in the gears are constraining the other end up against the bearings. So you get this nice setup, and it also means you can get a really compact jack shaft setup. So a jack shaft is really just a shaft that just free spins. In this case, if I wanted to have both these 2 shafts spin in the same direction, a jack shaft is a great way to do that. It'll spin, say, clockwise, counterclockwise, clockwise. And it also is a good way to reverse direction of different things. Bzeeb asked if the clip will work with thrust bearings. If you used it in combination with the thrust washers that come on the thrust bearings, it would work just fine. Yeah, that should work just fine. I've not really considered, but the downside is that there's not that much material in that clip. So in a situation that requires a thrust bearing compared to a normal flanged bearing, you may want something a little beefier like a clamping collar to bottom out against the thrust bearing. Generally, thrust bearings are great for really high side load applications, and that doesn't pair super well with an E-clip, but functionality-wise, it would likely work if you needed it for spacing or something like that. Of course, these do keep like the same old advantages of normal Rex shafting. The profile is the same aside from that groove, and it'll still work with round bearings or 8-Rex ID bearings and all of the additional 8-Rex parts. These are just kind of a nice upgrade. They're used in the Strafer chassis V3 and in the B-line just to make things a lot simpler overall and to make things really very easy. So it also lets you do some other kind of weird things that I would not have thought to do before we got some in our hand and played with it. This is an example where you can bolt a bearing to the end of a shaft and fully constrain it with a screw. So you can kind of sandwich it between a screw in the end of the shaft and of course, in addition to a washer and the E-clip. So now I've got this bearing on the end of that shaft that's fully captive, and that gives you a little bit of flexibility in a situation where you need a bearing to be captive and you're capturing that bearing against your chassis in a different way with something like a pattern spacer or a 1201. Anything with a bearing flange would work really well with this. My name is unavailable. Would this work with a flywheel axle? It definitely would. Let's see. I would recommend using an 8-Rex ID bearing and make sure you're running a balanced hub. I guess we don't have any non-bearing balanced hubs for Rex shaft, so I'm not really sure why that is important. But the 8-Rex ID bearings are just, in our experience, they're more they have better concentricity. So you should be able to run it at higher speeds and not risk any of your load being unbalanced. The 8-round ID on an 8-Rex, you just don't get a whole lot of material on the flats. That's a big reason we came out with the 8-Rex ID. And they are definitely nicer to use in heavy-duty and high-speed applications. If the concentricity of your shaft and whatever is mounted to it isn't super important, and if the heavy-dutiness of the shaft or the bearing system isn't super important, the round bearings can save you $1. They are definitely a little cheaper, but the 8-Rex ID I think is overall nicer and should be a better use for a lot of situations. I think that's a lot of the 2106 shafts. They're a really cool addition, and they're meant as kind of an incremental improvement over 2102 shafting. We have a really hard time being happy with really a whole lot of things we make. There's always like one more thing, and that's why you see a lot of parts gradually change, what we call running changes here in GoBuilda. Hubs went to a 2mm protrusion instead of a 1mm protrusion recently to work better with bearing counterbore parts. Or you've got, say, a 1201 with a 1mm deep 14mm round counterbore for a bearing to sit inside of it. If you had a 1mm bearing protrusion, or protrusion that's 14mm, all of a sudden your hub doesn't center with that part. So a lot of our hubs went to a 2 mil protrusion. Small things like that are always things that we like just making better whenever we can. And this is a great opportunity to make already our kind of premier shaft a little bit nicer. In this case, it got different enough that we needed a new series to say, hey, this shafting has threaded ends and a snap ring. And there are probably some situations out there where that means you wouldn't be able to use it in your exact build. So that's why it got a brand new part number, brand new series, and all of that stuff. Let's see. Just a reminder, 2106 is the keyword for our giveaway. You get some 4 individual shafts. So you can probably choose the length if you want 4 120 mil shafts. That's what you can get. If you end up winning, just shoot us an email to marketing@gobuilda.com. We will take care of you. You'll also get 4 of our kind of limited edition exclusive Mecanum coasters. They have our new Mecanums on them, and they're just kind of a fun thing to have. We probably won't ever sell these, so they are likely a more limited edition thing that not everyone will have. So they're really fun. I suppose they would be good, bad weapons, but maybe they'd be kind of fun. I don't know. If your Halloween spirit is really, really excited, you can throw some at your siblings or whatever. So that's a lot about the 2106 shafting. It is a fun improvement, and we're going to talk a little bit about the Strafer. So Strafer V3 is a lot of what we talked about for a few weeks now. It's our big flagship chassis, and it is really just kind of the best drivetrain that was Mecanum drive that we could design for FTC. That was our big goal with this iteration of the chassis, to fix every problem we had ever seen in this. So a big thing is now miter gears are spaced and located with thrust bearings. So there's no guessing about how your gear mesh works out. You just assemble it and it's smooth. That was something that a lot of teams did struggle with last year. It runs 2106 series shafts. An advantage of 2106 shaft is that it actually reduces cost, because you can get rid of collars in a lot of applications. So even though this chassis is a lot more feature-rich this year, it let us keep the price the same, because we could trade out a shaft and a collar for just a shaft, which is really nice. Noah says, can you make one of those CD mousetrap powered cars with the Strafer coasters? That would be funny. We definitely talked about it when we first got them in. I don't think they're a 1-to-1 scale. They're pretty close. So I think we'd have to drill the holes in the wrong locations for the hubs, but we should do that. That would be a lot of fun. Let's see. It got a little narrower, about 0.1 inches, just enough so that you can fit in the box a little more comfortably. My senior year, we failed world size inspection 7 times, so I definitely feel that as an issue. That hits close to home. And it's also now, the wheels are on pattern, so the height up from the chassis to the ground is now a non-pattern distance, which we found was really important for collecting rings this year with Go Build parts as kind of a bottom roller. So there are some things that you can do to, if you're planning on using your Strafer for years to come. There isn't anything in this chassis that's going to wear out. It uses steel gears, and it's all very, very solid. But a couple things you can do if you are expecting to play kind of rough against other teams. One easy one is adding some 43 mil standoffs to the channels. The very outside corner of channels can sometimes get crushed in match play, especially with defense. So that's a nice thing to do. I wouldn't worry a whole lot about your gear spacing changing from that standoff, because the channel width is really well set by the 1201 that the motor is mounted to, the quad block, sorry. Let's see here. I'll need a ball end hex key. Ball end versus standard end hex keys is a conversation we have a lot around here. Standard end hex keys are nice because they have a lot better fit with a screw. So if you are working with a smaller scale screw, or you're worried about stripping that out at all, a standard flat end hex key is nicer. That's what I use every time I can. It's a lot nicer. So having that really nice fit is important, especially on a 2.5 mil driver, where you just don't have as much meat in a lot of times what's a set screw. So there are always some applications that require a ball end. It used to be the reaching into a hub inside Mecanum wheels, old Mecanum wheels, you needed one. You don't anymore, thankfully, but depending on how you mount your hub in your wheel. Let's see. Bat Boy 2021. One issue we had with Go Build Parts is inspections. We had to file down the edges. I've not experienced something similar. So I competed in Iowa in FTC, and the way, at least events I was at, generally did sharp edges inspection was they asked to see your hands, and if your hands had cuts on them, they wouldn't look for sharp edges on your robot, because they figured you'd be touching your robot way more than volunteers would. So we always passed there, but I totally get that. The sharper corners on Go Build a Channel is something we have heard, and it's something we're always looking at as a possible change. Let's see. Keterin asks, can you still buy the old wheels anymore? One thing we've mentioned is some teams either are getting a promo Strafer or want new wheels in general. So you may ask if anybody wants to sell their old wheels secondhand. There's not a whole lot to wear out. I actually have a really well-used wheel, really well-loved wheel right here. And the biggest thing that happens is that the yellow rollers get a little gross. You can clean them. I think the thing that I've seen the most success with is rubbing alcohol, actually. But you can clean them and make them a little nicer looking. And if that robot was dropped, it's possible that the plates could bend and have the rollers in contact with each other. In that case, you can grab a screwdriver and bend that plate back out so that the rollers aren't in contact. This happens a lot on Nexus wheels too. A lot of competitions I go to, I check people's wheels because it happens every once in a while, and it does happen. You see it on a Go Build a wheel because the rollers were yellow. So anymore, their plates are steel. It's not really an issue anymore. That's one thing we fixed on version 2. You can drop a robot and the wheels don't crush as easily. If you drop it from very high up or if it's very heavy. We didn't do extensive testing on that, but it's a lot nicer now. But really, a big reason we went and discontinued the old wheels is that we had a conversation up here in research and development and said, where are applications where the old wheels are better? And we couldn't think of anything, which is really weird for us. We normally talk a lot about and have a lot of disagreements on parts and applications, so having a real unanimous decision of these are better in every application, there isn't an interference problem with anything. It's possible they do get a little smaller, so if you have 2 millimeters of ground clearance, your chassis will touch the ground. But we went completely with these new wheels because they were really just better. They're a lot grippier, they're narrower, they are a lot easier to work with and interface with, and they're a lot smoother. We used C-clips on the Mecanum wheel shafts instead of screws and nuts because it lets us really, really precisely control the length of that shaft, and it means we can keep these rollers spinning really, really well compared to a system where you can accidentally tighten down the roller too much and have it not spin as freely. If you want, let's see here. Let's see, besides standoff, what's a good way to add strength to Go Build a C channel? Standoffs are a great way. You can, I know Baron in the chat mentioned putting 2 pieces of channel back to back. That's what we call boxing channel. You can see it back on this table frame right here. That's a great way to. GoTube is actually insanely rigid. Even though it's 0.07 mil wall, it is thin wall channel. But it is way more rigid than channel and low side channel and go rail. So what I've seen some teams do is actually run a length of GoTube down their C channel and affix it with a quad block on either end. So that gives you a lot of the rigidity from the GoTube and the mounting structure from channel. It is a little more annoying to to gradually change your robot because you have to take that go tube out to mount things with screws to the top of the channel. But if you're not doing that much, or if you have more of a final product, that's a really great way to make your channels extra rigid. You can also, down the length of that go tube, add a 32 millimeter ID clamping mount. That would be a good way to even more increase the rigidity of the system. Circles are a really strong shape in the twisting and that direction, really, because that's a lot of what channel isn't amazing at in terms of rigidity. You could add a ton of standoffs. That would be a great way to go. Or another thing I've seen some teams do is box low side channel. There we go. One fun thing is that M4 lock nuts are 7 millimeter hex, or M4 nuts. That also means I didn't grab a 7mm wrench, I grabbed a 3/16 wrench. That means that standard wrench, combination wrench you would use in Gobilda will go around an 8 Rex shaft. So if you are in a situation where your standoff is really stuck, you can put that wrench around it and really get a lot of pressure around that. Torsion, I suppose that is probably correct. Boxing low side channel is a great way to get a really rigid structure. You can do that back to or face to face like this, where you have a more traditional box tube shape. One other thing I've done in the past is this kind of I-beam like structure, or you just bolt two pieces of low side back to back. That is a really strong shape. You see that all over construction. It is really cool. I made a whole pan and tilt using this construction method, and it gets you a little more rigidity compared to standard channel. Low side channel and normal channel will still be a lot more rigid than a pattern plate or a grid plate, because you get this L or this U shape really does add a lot of rigidity in kind of this bending direction. But torsion is not, it's still very good. Like if you have two crossbars on a chassis, it's really hard to twist this chassis. But if you have one channel, it might not be quite good enough. But one go tube has no problem. We've run a bunch of test chassis with one piece of go tube and it works just fine. Let's see here. Okay, so a big thing you can do to chassis to help keep them together through match after match after match at competitions is Loctite. So most projects around here, if we need Loctite, we use 220. That's blue Loctite. It comes in a red bottle, but the text is blue, and the actual substance inside of it is blue. This is their medium strength, and it's generally removable. To use that, it's fairly simple. I'm going to apply it to one of the set screws in the 8 Rex here. Whew. These were pretty tight. I'll apply it to one of these set screws in this chassis here. If I can. We'll do a normal M4 screw. I suppose somebody really tightened those down. So just take your normal M4 screw and your Loctite. I like having them on a kind of flat end hex driver because it makes it a lot easier. And you're just going to apply a little bit of Loctite to that screw and screw it in. You generally have a good amount of time before this sets. I feel like its spec is 24 hours before you get the full strength out of it. And that's a great way to make sure your set screws and other screws are just a little more reliable. In some of our really fast RC builds, we do use Loctite on most of the components, especially mounting the motors. There aren't a whole lot of times where one screw in a set of 4 screws on a Strafer chassis backing out will mean your chassis stops working. It generally takes a lot to fail on this chassis for it to stop working. The set screws on the motor side, 6D miters, can come out and it's fine. One out of every one of the 8 Rex shafts, set screws can come out and that's perfectly fine. You've got 2 on each one. And even then it will still drive until the shaft falls out, if it does. A lot of times, you'll end up marring that, which makes it a little tough to get an 8-rex part off, an 8-rex set screw part off the shaft. So that can actually increase everything throughout the life of a chassis. So that's a great place to add Loctite as well, just to make sure those don't ever come loose. But it generally takes a lot to come out before a strafer fails. One thing that really only takes one screw to come out before it would fail, or one wheel would lock up, is the motor mount screws. If the screws that go through the quad block, through the pattern spacer, into the motor face come out, they can interfere with the gear. So that's a great place to add a thread locker, if that's Loctite blue or red. Red is a lot harder to remove and generally will require heat, and occasionally will require getting the Dremel out and really getting that screw out. But if you know it needs to stay there forever, Loctite Red is a great way to get there. So those are an important ones to check over before every competition. You actually have holes on the 16 pattern on those gears, so you can reach through the gear and tighten everything up if that's something you end up needing to do. You also want to double check the screws on your hyper hubs and the screws on your wheels. Since those spin around, they are a little more common to fall out. Generally, if stuff is tight enough, it should never fall out, but if something does, those are rotating, so that makes it a little more likely. So double check those before you go to competitions generally, and you should be pretty good to go. There really is not a whole lot that you can improve in the way of reliability on this chassis. We really tried our best to make it so there's not really anything to go wrong. In our design process for this and the B-line, a crucial step is always sitting down and saying, hey, what breaks? And the B-line, I still can't think of anything, but the strafer probably would be one of the screws backing out. I suppose that could be an issue on the B-line too. But thread locker and overall making sure screws are tight is a really, really great way to get there and make sure that your chassis is really reliable for competition use. And generally takes a long time for something to come into play. So double checking all of your mechanisms, making sure screws are tight before competitions, and even in between matches or in between days of competitions is really important. And it's something we always recommend doing. It was part of our pre-flight check before we leave to a competition on Recharged. Noah asked if we can show off our RC builds. I don't think I have any put together that use parts that are currently released. RC stuff, we normally will run brushless setups, and they're a great way for us to really, really battle test our products. So miter gears are a great example. I had an RC chassis that ran 4 yellow jackets through one set of miters, and we ran the heck out of that chassis. We then switched over to a brushless motor and ran it faster and with more power, and those gears all stayed together and really didn't experience very much wear. The only thing that wore was a little stripe of the 8mm Rex shaft where I had assembled it incorrectly. So it really, the RC systems that we create are generally used for really, really stress testing parts. And that is, so generally after they're kind of served their usefulness, they get taken apart and used for parts on other builds. So I don't have any together right now that I can actually show you guys. But most of the time they're just kind of simple looking RC cars or skid steer setups, differential drives, stuff like that. Andrew says unreleased E. Yeah, we do have a lot of parts that are coming down the pipeline that we're really excited about. Some of them may not be primarily FTC parts, but definitely some that may end up being used in FTC. It's hard to really know what will end up being useful in what game in a game from one year to the next. Let's see. Should we use, okay. Stealth Biplane asks, when I suppose he meant gearing 2 yellow jackets to 1 axle, should we use 2 motor controller channels or put a Y harness? 1 encoder or separate encoders? So I always recommend using 1 motor per channel. Having multiple motors per channel is really not what those motor controller channels are designed for. So it also generally, the applications where you want to gear 2 motors together are lifts and shooters, which are both traditionally high current draw applications where you're putting a lot of stress on those H bridges to begin with. So putting double the current through that really is not a great thing to do to them. I've heard of it being a failure point like once or twice. So it's really not very likely, but there really isn't any advantage to running to one port. So it's really easy to just run to two and keep those two powers separately. 1 versus 2 encoders. If you're running an odometry system and you don't have a plethora of quadrature encoder ports, running one encoder and running a custom PID loop would work pretty well. But just running 2 encoders and running separate PID loops is also a pretty good way to go. On that front, there's not a whole lot of difference between the two. They both work out fine, but running 2 separate encoder wires is probably a little easier because you could use like the built-in run using encoder stuff in the SDK. Can we get a teaser? Oh man. There are definitely going to be some more 8mm Rex-based parts in the future. That'll be as much of a teaser as I think you guys will get today. But more 8Rex stuff in the near future, I'd say. 8Rex is the way we're going. We really love that shaft's size and form factor. It plays super well with 14mm holes in GoBuilda, and it's really, really tough to break. I think we had one of our test builds hit a curb at like probably 20 miles an hour, and it was fine. Where 6D shafts definitely bent in that same situation. So, yeah. I think it's about time we would roll for our giveaway. So make sure to get in 2106 series shafts, 2106 in the chat for your chance to win. Make sure you're following also. Andrew asks if we're going to see 10mm Rex soon. Probably not. We don't see a huge use for it compared to 8 or 12 Rex. Elon asks what I'm dressing up for as Halloween. I don't really have anywhere to go this year, so I don't have any specific plans. I might go with the old tried and true and just be a Jedi, break out my original first lightsaber and go that route. But unless somebody invites me to a Halloween party tonight, I don't really have anywhere to go. Definitely let us know if you post on Instagram, have some GoBuilda related costume or have a little GoBuilda in your costume. Tag us on Instagram. We always love to see stuff like that, even if it is just a story. So we're going to go ahead and close our entries for our giveaway. Maybe. We'll refresh the page and try that again. And we'll go ahead and roll and figure out who won those coasters and that 2106 series Rex shaft. There we go. All right, it looks like Elon9421. I don't know what is up with your luck with winning giveaways. I don't know who you paid, but shoot us an email to marketing@gobuilda.com and you can get your fancy Mecanum coasters and your 2106 series stainless steel Rex shafting. And that's really about all we've got for you today. Thank you guys for joining in. We had a really fun stream today about some fun stuff. And we'll see you again next Friday. If you have any questions for us, you can always shoot us an email or tech@gobuilda.com. And if you want to follow us on social media, we're at GoBuilda pretty much wherever. You can find me on Discord and Reddit. And with that, we'll see you guys later.